Grup kami, grup F3 akan bincang tentang discussion dan conclusion. Untuk eksperimen 1, dipersilakan Fauzan.
Discussion untuk eksperimen 1 iaitu capacitor measurement ni. Untuk soalan 1 dia, state your observation on the vibration of the V out AC in table 1. Jawapan dia, when the value of resistor increase, the value of voltage output record increase. As the value of capacitor decrease, the value of voltage output increase. Untuk soalan 2 dia, please explain the need of turn off the function generator before charging the capacitance value at the capacitance decay box. The capacitor can be charged to the necessary voltage and then discharged quickly to provide the energy needed. It is even possible to charge several capacitors to a certain voltage and then discharge them in such a way as to get more voltage out of the system than was put in.
Alright.
Okay, soalan ketiga dia, from your observation, please identify the best impedance combination of Webstone bridge and explain why. The Webstone bridge can be modified in a couple of ways to measure capacitance. The circuit below use a variable capacitance to balance the unknown capacitance, Cx. When the bridge is balanced, the relationship R1 over Xc1 equal to R2 over Xcx will hold true. We can simplify this relationship by noting that Xc equal to 1 over I omega C on both sides of the bridge. Therefore, equation 2 R1 omega C1 equal to R2 omega Cx2. But the same signal is applied to both legs of the bridge circuit. So omega is the same, and of course I is also the same. On both sides of the equation, therefore the expression for balance reduced to R1C1 equal to R2CS, or CS equal to C1 times R1 over R2.
Okay, nice. Okay, boleh proceed number 4. Eksperimen 1 tu.
Nombor 4 lagi.
Number 4 in practical aspect suggest that the to measure the value of unknown capacitor. Please elaborate investigation in terms of diagram and equation. Itu saja. Yang pertama, symmetrical bridge. Lepas tu ada dia punya diagram dalam report. Yang kedua, wind bridge. Yang ketiga, bridge.
Maxwell wind bridge. Okay. Okay. Dan untuk eksperimen 1. Untuk eksperimen 2 pula, first question dia, illustrate the graph that shows the relationship between resistance and voltage drop of the potentiometer. What is the conclusion to be obtained from the graph? Okay. From the graph, we can see that the voltage and the resistance is directly proportional due to the voltage by the rule formula. That is VBC equals to RBC over R total times voltage. So that means the voltage is directly proportional to the resistance. Okay, untuk soalan kedua, if all the resistor in figure 5 were 20 times larger in voltage, what is the value of the voltage drop? And how would the power dissipation be affected? Okay, from the formula, there is a voltage divider rule. We can see that the value of voltage will remain the same because the ratio of the resistance is constant. Okay. Untuk power dissipation pula, formula dia P equals to I square R. It shows that the power dissipation is directly proportional to the resistor. So the power will be 20 larger than actual value. Untuk soalan ketiga, in practical devices, it is not possible to obtain exactly 0 volt or exactly P volt at the extreme end position of potentiometer. Why? Because the value of voltage will not be exact 0 volt, because there will be some voltage drops across the resistor. This voltage drop may be detected by potentiometer. The other reason may be makes the value of voltage not exactly correct because the potentiometer has some reading error. Untuk soalan yang keempat, explain the operation of potentiometer as voltage divider in detail by explaining how the wiper the resistance and voltage drop. Please include diagram if necessary. Conclude the relationship between resistance and voltage drop at the potentiometer from the experiment. Untuk soalan nombor 4 ni, the potentiometer is a terminal resistor with a sliding contact that forms an adjustable voltage divider. Connection are made to both ends as a wiper when using the potentiometer. The position of wiper will provide the output, which is the value of voltage will be varied at one side and the at other side. Basically, there will be label B of the adjustable contact that can adjust so that the contact between resistance A and C at any point. As the contact is moved down, the resistance B and C will be decreased and otherwise. Using the voltage divider rule formula, value of voltage is directly proportional to the value of resistance. So if the value of resistance is decreased, value of voltage also decrease. Okay, done for the experiment 2. Okay, next experiment 3. Linear variable differential transformer, LVDT. Question 1 is, what is the shape of the graph, especially over the central section? The graph is sine wave. The shape of graph over central section is decreasing from 10 mm to 15 mm. Okay. Soalan kedua, discuss the output obtained from the graph. State your observation on of the variation of the output voltage peak to peak from 1 mm until 25 mm in table 7. The graph increases from 0 to 10 and then decreases from 10 to 15. Finally, the graph increases from 15 to 25. You can see the graph in the diagram. Soalan ketiga, draw in what you consider the best straight line approximation to the central section, which will most likely pass through the zero null point. Okay. Graf ada dalam lab report. Okay. Soalan number 4, measure the maximum distance of your curve from the straight line in the vertical direction. Express this as a percentage of the total output voltage range between the two peaks. Maximum distance dia 6.4 minus negative 8.4. So maximum distance dia 14.8. Okay, distance between two peak 7.4 minus negative 8.4. So the distance between two peak is 15.8. Percentage 14.8 over 15.8 times 100. That is 93.67%. Okay. The last question is, between which position is the output within the linearity figure? This represent the range of the transducer. Express this as a figure of plus minus y millimeter about the null point. The answer is plus minus 5 millimeter. Okay, jadi itu saja untuk discussion. Boleh teruskan untuk conclusion.
Thank you, Riyad and Fauzan, for the discussion. And now we proceed to the conclusion. This is our conclusions. Instead of read whole conclusions, I will read certain points that we will emphasize on. From this experiment, we found out the characteristic of capacitance. The most important characteristics of capacitor is its capacitance, C. The capacitance, which is C, describes the property of capacitor capability to store electrical energy. Voltage U is applied. Capacitance denotes how many units of charge can be stored in the capacitor per voltage unit. The working voltage is another important capacitor characteristic that defines the maximum continuous voltage, either DC or AC, that can be applied to the capacitor without failure during its working life. And then the characteristics for linear variable differential transformer is it consists of high input and high sensitivity. The output of LVDT is so high that it doesn't need any amplification. The transducer possesses a high sensitivity, which is typical about 40 volt over millimeter. Other than that, it consists of low power consumption. The power is about 1 watt, which is very very high compared to the other transducer. And then last but not least, the principle of linear variable differential transformer is an absolutely measuring device that converts linear displacement into an electrical signal through the principle of mutual induction. Its design and operations are relatively simple, providing extremely high resolutions in a device suitable for a wide range of applications and environment. That's all for our video.